So, hi everyone, and welcome to this particular video on the consumption savings model, in particular, the case where we have heterogeneous agents. So, when we have heterogeneous agents in the model, the problem becomes a little bit more complicated because we have to deal with, each person's or each agent's utility maximization process. But if there are certain sort of commonalities between them, then the problem sort of reduces to a relatively simple one, which we can apply our market clearing conditions and solve. So we're given here with a problem that says, consider a model with two types of agents, and these agents live for 3 periods. And the utility is given by a log utility function for both, wherein there's a different beta for each household or each agent. So beta 1 is equal to 0.98 and beta 2 is 0.95. Okay. We also know the following. Y11 is 0, Y21 is 11, and the Y31 is equal to 12. Okay. Then we know Y12 is 10, Y22 is equal to 11, and y32, okay, is going to be equal to y32 is equal to 0. Okay, I just forgot 0, right? So what we're going to do first, okay, is sort of we're going to first define an equilibrium. So definition. So a competitive equilibrium is a vector C1i, C2i, C3i, I is equal to 1 to 2, R1, R2, such that, okay, first, given R1 and R2, the allocations C1i, C2i, C3i, that is all the consumption allocations for both agents, solves the Umax problem, which we know is given by maximize C1i, C2i, C3i, and then this is the utility function I, because the utility function is similar between them, so we can generalize C1i plus beta I ln C2i plus beta I squared ln C3i. Okay. And this is subject to your typical constraint, I plus C2i over 1 plus R1 plus C3i over 1 plus R1, 1 plus R2, which is equal to Y1i plus Y2i over 1 plus R1 plus Y3i over 1 plus R1, 1 plus R2. Okay? So we have that there. And the second one is that the market clears. So given R1 and R2, the market clears. So that's basically sum of I. CTI is equal to sum of I, YTI for all I, 1 and 2. T is equal to 1, 2, 3. So we have the two conditions that define our equilibrium. It must be that the consumption allocations maximize utility subject to the constraint, and that the market will clear, right? So that's our standard conditions. Okay, so now we need to find a way to solve for it, right? So if you think about it, okay, for each agent, okay, so how do we now, the only thing left for us really is to solve for what R1 and R2 is. So here we solve for R1 and R2, right? Solving for R1 and R2. And doing so, okay, how would we get that one? Well, what we can do now is we can go from the Lagrangian. right? So we can form the Lagrangian. And from the Lagrangian, we have, say, ln C1I plus beta I ln C2I plus beta I squared ln C3I, right? Minus lambda times C1I plus C2I over 1 plus R1 plus C3I over 1 plus R1, 1 plus R2. Okay, then I'm gonna let this entire thing be equal to star. So it's just gonna be minus star. And then like that. Okay. Then I use the first order necessary conditions of F1Cs. So first with respect to C1I, so I do that. Derivative of the first term with respect to C1I is 1 over C1I, okay? Minus lambda is equal to 0, which implies that lambda is 1 over C1I. Okay, makes sense? Then if I derive the next term, C2I is going to be beta I divided by C2I minus lambda times 1 over 1 plus R1 equal to 0, which implies that lambda is equal to beta I 1 plus R1 divided by C2I. Okay. Lastly, okay, C3I, we get beta I squared divided by C3I minus lambda 1 over 1 plus R1, 1 plus R2, right, equal to 0, which implies that lambda is equal to beta I squared, 1 plus R1, 1 plus R2, divided by C3I. So that's what we have so far. Let's call this 1, let's call this 2, let's call this 3. And so if I equate 1 and 2, I get a 1 over C1I equals beta I 1 plus R1 C2I. Then I rearrange it, I can get basically C2I over C1I, right, equal to beta I 1 plus R1. Right? And this is the first key thing I wanted to derive, right? Which is sort of like in our first order equation. The next thing I want to derive is if I equate 2 and 3, okay, I get a 1, so this will be beta I 1 plus R1 over C2I, beta I squared 1 plus R1, 1 plus R2 divided by C3I. So if I solve for C3I divided by C2I, that will be equal to beta I 1 plus R2. Okay? This is the second order equation I wanted. Right? So I'll have those two order equations with me now. I can actually do something with that. Okay, so basically, okay, what I can show from here, okay, from this first one, I can show that, if I multiply this to this side, I can show that C2I is equal to beta I 1 plus R1 C1I, right? In here, for this one, I can show that C3I is equal to beta I 1 plus R2 C2I, right? So I basically now have an intermediate form, okay, for what these two values could be or should look like, okay? Then I'm gonna appeal to my market clearing conditions, appeal to market clearing. So the market clearing conditions, there will be 3 because we have 3 periods. It must mean that C11 plus C12 is equal to Y11 plus Y12. And this basically means that, I don't know what those C's are yet, but I know the income. So this is going to be 10 plus 0 plus 10, right? So this will be 10, right? This will be C21 plus C22, Y21 plus Y22. Again, I don't know what the C's are, but I do know what the y's are. So I can infer from there that this is going to be equal to 22. Lastly, C31 plus C32 is equal to Y31 plus Y32. This implies to me that it's going to be equal to, again, not knowing the C's, I'm going to make this equal to 12. Right? So I have the three market clearing conditions. I'll label this 4, 5, and then 6. So now, okay, so notice we have C2 and we have C3, right? Now let me use, okay, let me use C2. Let me use 5. Use number 5, okay? I know that C21 plus C22 is equal to 22, right? Well, C2 1, I know will take the form, okay? Based on this particular formulation here, I know this must take this sort of form. So it's gonna be, it means that C21 plus C22 is equal to beta 1, 1 plus R1, C11, okay? And I know that, well, see this other form here, okay? C22, okay? C22 must take in particular, okay? This formulation plus beta of the second agent times 1 plus R1, C, okay? This one will be C1, 2, right, instead, right? So because I know that the second period consumption for each agent, just 1 and 2, so this one will change, right? Those i's will change. I can get this particular result, right? Very straightforward, okay? And if I simplify, okay, I can get that basically C21 plus C22 is equal to, well, both of them have a 1 plus R1, right? Then it's beta 1 C11 plus beta 2 C12. And that implies further that C21 plus C22 is 1 plus R1 times beta 1 is 0.98, right? C11 plus beta 2 is 0.95, C12. I also know that that in fact is equal to 22. So this is equal to 22. Right? So from here, rearrange. So we get 22 is equal to 1 plus R1 times 0.98 C11, 0.95 C12. Further rearrange, I want to isolate out the R1. So let me do 1 plus R1 here equal to 22 divided by 0.98 C11 plus 0.95 C12. Okay. So basically, we now know what R1 is for as long as we have whatever these things are. So if we can solve for what those values are, we're done, basically. Well, if you recall, okay, we can actually do that, right? So we have here values, so we can solve for what the optimal C's are. So we have here C2i and C3i, okay? We can get a value for C1i and the others, and then we can solve. And what we'll find is that, well, the value of C1, 2 and C1, 1, okay? What we're gonna do is, okay, so let's do this one. Let's solve for C1i, right? Why are we doing C1i? Because we have here C2i and C3i, therefore we can get out C1i, right? So to do that, basically, if you solve it, you're gonna get C1i is equal to 1 over 1 plus beta I plus beta I squared times Y1i plus Y2i over 1 plus R1 plus this is Y1, 1, Y2, this is Y3i 1 plus R1, 1 plus R2, okay, right? And if we solve this, okay, so what we're gonna find is, well, for agent 2, C12 is 4.20610 plus 0.20610 C11, right? That's what we will get, right? Then, since I know that this is C12 by market clearing, I know that C11 plus C12 is equal to, okay, 10, right? So that should be equal to 10. Therefore, it must be that, okay, it's gonna be 4.20610 plus 1.20610 C11 is equal to 10, right? And if I solve for C11, it's gonna be 4.80483, right? And if I solve for C12 now, it will basically be, if I plug it back to market clearing, it's gonna be 5.19638. Okay, so now having solved for those C1 terms, okay, I have the C1 terms, okay, there. Okay, well, what I'm gonna try to do now is I'm gonna try my very best to plug it back in to the original function. So notice these are the functions we needed. So we needed C11. Okay, so that's, okay, 1 plus R1 is equal to 22 over 0.98. C11, well, that's just 4.80483. Then you do plus 0.95 times, okay, 5.19638. That's going to be equal to 2.28090, which means that R1 is equal to 1.28090. So that's how to get R1. And if you do the same procedure, okay, for R2, knowing everything in R1, you can just plug into one of the C's. You can get that R2 is going to be equal to negative 0.43462. So that's a little bit of a lengthy solution, but it sort of tells us how to solve, okay, a representative agent, a heterogeneous agents problem, okay, wherein we have two different betas in the consumption savings frame. So thank you for your attention, and I'll see you in the next video. Thank you very much.